masses are immense bodies of air characterized by their relatively uniform temperature and humidity properties. These colossal air masses originate from source regions spanning from snow-covered polar areas to arid deserts and tropical oceans. The longer an air mass remains over its source region, the more it assimilates the qualities of the underlying terrain. They can be classified into several types based on temperature and moisture characteristics. Arctic. These extremely cold and dry air masses develop over Arctic surfaces of ice and snow. Polar, relatively shallow and cool to cold air masses that develop over high latitudes. Tropical, warm to hot air masses originating from low latitudes. Continental, dry air masses that develop over land. Maritime, moist air masses that develop over water. Fronts are dynamic boundaries where different air masses interact. These collision zones are defined by their distinct temperature and humidity differences. There are several types of fronts, each with unique characteristics. Cold front. This occurs when a mass of cold, dense, and relatively dry air advances and displaces a body of warmer, moist air. This leads to the rapid ascent of warm air, creating towering cumulonimbus clouds, heavy rainfall, thunderstorms, and temperature drops. Warm front. This develops when a warm air mass advances and replaces a body of colder air. Warm fronts move slowly, creating widespread layered cloudiness, precipitation, and temperature fluctuations. Stationary front. This forms when forces of two air masses are relatively equal, resulting in a stationary boundary. This front influences local weather for extended periods, leading to a mixture of conditions found in both warm and cold fronts. Occluded front. This occurs when a fast-moving cold front overtakes a slower-moving warm front, forcing the warm air to ascend. Two variations include cold front occlusion and warm front occlusion, each with its own weather patterns. Understanding these different types of air masses and fronts provides valuable insight into the mechanisms driving weather system development.